Yes, good morning, my dear students, and also welcome to electronics online classes. Look here, in the previous class, we are discussing about the important applications of your, or can say special applications of the operational amplifier, and we have completed about how actually we can convert the D to A converter. It means we can, by using op amp, we can convert digital signal into the analog signal. And as we know already, we have studied already in the last class, in your computers, the computer understands only the digital signals. It understands, it processes the data in terms of digital. But the human beings, you are familiar with the analog signals. Now I am speaking something. This is in terms of analog. But same signal, if you want to give to a computer, that does not understand. It means we want the conversion in the input side. And also, if the computer, the processor data, that data also in terms of digital. But the human being cannot understand the digital data. Once again, you want conversion. It means the necessity of D to A converter and A to D converter is so important in electronics. And you have already discussed in the last class, op amp can be used as a to convert digital analog signals. By using the special application of the op amp, we can convert the digital signal to the analog signal. And maybe you have studied already, there are two types of and maybe today's lecture is lecture number 11, the lecture number 11, and as you studied already about R, 2R, ladder. It means you can study or you can convert digital analog signal in two ways. There are two methods to convert the digital signal into the analog signal. One is R to order ladder network, and another is called binary weighted binary weighted resistor. It means already we discussed in the previous class. Here we are using two resistances. The value may be R may be 1 k ohm and 2R we are using 2 k ohm. And especially here your op amp is used as a buffer amplifier. Here you are using an op amp, the op amp is used as a buffer amplifier. And as we know already, the buffer amplifier, nothing but it is a type of amplifier. It is basically the operational amplifier. But important thing is about in buffer amplifier, the voltage gain is 1. The voltage gain is 1, or it is also called as voltage follower. It means the output voltage follows the input voltage. And revealing about by using R and 2R, you are connected in the fashion of ladder network, and that you are connecting to the non-inverting terminal, and will get the, if you apply the digital signal at the input, will get the output will get the analog signal, or you will get the analog voltage at the output. And that is one type of D-to-A converter. Another is called binary weighted resistances. Here you are using nearly about 5 resistances. You are using about R, 2R, 4R, 8R, and you are using an RF is equal to R. You are using a feedback resistance. And here your op amp is used as an adder, or it is used as a summing amplifier. It means this much you studied in the last class about how you are converting digital into analog signal by using R to ladder method and by using binary weighted resistor. And actually in the today's class we go for in the today's class we go for the how you are converting the A to D converter. Yes, you have completed the D to A converter. Now we look for to convert analog to digital converter. Especially here it is also called as ADC. It is called ADC. It means as you have studied about D to A converter, it is very simple because you are using only the op amp. It may be it is used as a buffer amplifier or it is used as your summing amplifier. But if you go for the analog to digital converters, it is some complicated. Not complicated, it requires so many things. And as usual, the analog digital converter, nothing but here you are applying the input as analog, but you get the output as digital. For example, I said if I saying something that is in terms of analog, this analog signal cannot understand by your computer. It means the computer understand only the digital signals. It means it is not possible to directly can give it to your computer. And maybe I already said it so many times, it is as similar to the modulation and demodulation. The modulation that occurs in the transmitting section, but demodulation that occurs in the receiving section. In the same way, how you are studying about modulation and demodulation, they are opposite processes. In the same way, the ADC and DAC, they are the opposite process. Another digital converter, they are the two opposite processes. And you have studied already about the DAC, but if you go for the ADC, the ADC consists of four important blocks. It is having the first important, it contains a binary counter. It also requires the comparator. It also requires the D to A converter, and finally it requires an AND gate. It requires an AND gate. It means to understand about analog to digital converter, the analog to digital converter consists of binary counter, comparator, and D to A converter, and AND gate. And especially in the overall A to D converter, the important thing is about comparators. The comparator is having very important role while converting analog to digital signals. If you want to convert analog to digital conversion, if you are applying analog signal as input, you want the output digital signal, the important thing is about you are using the comparator. And before going for the analog to digital converter, you go for the comparator. Once you understand about the comparator, then you can easily understand about how to can convert analog into digital signals. And first you go for the what is called comparator. We go for the comparator. It is so important thing in your op amp. I can write op amp is used as a comparator. Look here, it is so important concept in operational amplifier, and already you studied about basics. Actually, the op amp can be used to construct the linear applications and non-linear applications. Especially the comparator, it comes under non-linear applications. By using op amp, you can construct the comparator, or op amp can be used as a comparator. And what is comparator? And what are the main function of comparator? And what are the types of comparator? and what is the use of comparator. Especially in your operational amplifier, you already studied in detail about the characteristics. There are two important characteristics of operational amplifier. One is ideal characteristics, another one is the practical characteristics. Ideal characteristics and practical characteristics. And also you have all completed linear applications, especially in the before going for the comparator, you go for what is called, maybe I said already, what is called open loop, what is called open loop system, and what is called closed loop system. What is called open loop system, what is called closed loop system. Maybe I said in the beginning of feedback amplifiers, or maybe in the time of beginning of your operational amplifier. In your open loop system, the system without feedback. In open loop system, you are not using any feedback. The gain without feedback, or it is also called as the open loop gain. Open loop gain. The open loop gain nothing but gain without feedback. That is nothing but the open loop gain. And closed loop nothing but the gain with feedback. The closed loop system nothing but gain with feedback. And especially maybe I said in the good example, open loop gain nothing but example you take the fan without regulator, and closed loop gain nothing but or system nothing but the fan with the regulator. In your open loop gain, sometimes the output may changes. The changes in the outputs does not known by the input. But here, whatever the changes in the output, that is known by the input. That is a major difference about open loop configuration and closed loop configuration. And maybe you have studied about so many applications of the operational amplifier. It may be your op-amp is used as an inverting amplifier, op-amp is used as a non-inverting amplifier, op-amp is used as an adder, subtractor, integrator, differentiator. Also you have studied about op-amp can be used as a logarithmic amplifier, anti-logarithmic amplifier. In all the cases you are applying the feedback. They are all called the closed loop systems. Whatever you studied up to this, you have completed the different applications of op-amp, how op-amp can be used as inverting amplifier, non-inverting amplifier, and it is also used as a adder, subtractor, integrator, differentiator, and logarithmic and anti-logarithmic amplifier. In all the cases you are using the feedback or you are using the negative feedback. Especially in all the cases you are using the negative feedback. And as usual, they are all called the closed loop configuration. Op-amp is used as a closed loop configuration. It means to go for the inverting amplifier, non-inverting amplifier, adder, subtractor, you are considering a closed loop system. Means you are applying the feedback. You are applying the negative feedback. And as usual, if you apply negative feedback, the gain that depends only on the RF and RI. The gain, the voltage gain that depends only RF and RI. The RF nothing but the feedback resistor and RI nothing but the input resistors. It means in your closed loop system, the gain depends only on RF and RI. And now today we go for the comparator. In comparator, you are considering the open loop system, or you are considering the open loop configuration. As you already studied about in detail about closed loop system and what is the necessity of negative feedback in your operation, you have studied in detail. And now today go for the open loop system. Open loop system nothing but system without feedback. System without feedback. And it means in your comparator, the comparator, it is a comparator. The comparator nothing but especially in your comparator, it is a type of closed loop, it is a type of open loop system. The comparator, it works on the principle of open loop system or combination. The comparator is working on the principle of open loop system. It means in your comparator you are not applying any feedback. In comparator you are not applying any feedback. It is called open loop system. What is comparator? The comparison circuit or device, it is working on the principle of open loop system. It means in comparator you are not applying any feedback. The first important thing. And basically, what is comparator? Their name indicates their meaning. Their name indicates their meaning. Comparator compare the two input signals. The comparator will compare the two input signals. The input signal will be current or voltage. The comparator will compare the two input signals and it will give the output. The output indicates in this two input which one is larger in magnitude. Once again I repeat, the comparator is basically an open loop configuration or open loop system. It means in comparator you are not using any feedback. And comparator nothing but it is a circuit or device. It will compare the two input signals. It will compare the two input signal and it will give the output. The output indicates in these two inputs which one is larger in magnitude. The output indicates which one is more in the magnitude. The two inputs, which input is maximum as compared to the two inputs. That is something but in simple way of your comparator. And especially as you know already in your open loop gain, the open loop gain of your op-amp is ideally is infinity. Ideally the open loop gain is infinity, but practically the open loop gain is something but practically it is nearly about 10⁵. It means you are not applying negative feedback in your comparator. If you apply very small input voltage, if you apply the input Vi 1 millivolt, but you get the output nearly about 100 volts. If you apply very small input voltage to the your op-amp, it will give the output 100 volts. But it is practically not possible. The practically is not possible. As you know already why it is not possible. The important thing in your op-amp, the important thing, the output should not more than the biasing voltage. The output should not more than the biasing voltage. It may be the output should not more than positive saturation or the output should not more than negative saturation. Always output should be in the range of positive to negative saturation. It means your output should not more than the biasing voltage. Or you can write about V0 equal to plus VCC or V0 equal to minus VE. That is the condition. It means because of open loop gain we may get more output voltage, but it is practically not possible. And the thing is that the output voltage should not more than the positive and negative saturation voltage, or output voltage should not more than positive and negative VCC. And as usual in your op-amp you are applying the minimum 12 to 20 volts. You apply the biasing voltage 12 to 20 volts. This is about in brief about your comparator. And actually the comparator, you see the block diagram or your comparator. In your comparator, it is having an open loop configuration and it is only having the two inputs. It is having two inputs and input maybe we can get the positive VCC and negative VE, and here maybe you can apply the input here, you can apply the input here, V in, and here you can apply the reference voltage. You can apply here the reference voltage. VRF. Actually, what the comparator do? The comparator compare the two input signals. The comparator will compare the two input signals. And as usual, we know about the output. The output voltage in comparison in your op-amp is nothing but V0 equal to A into V1 minus V2. Or the basically your op-amp is nothing but it is a differential amplifier. They will amplify the difference between the two signals. Basically your op-amp is a differential amplifier. They will amplify the difference between the two signals. It means this is the difference between the two signals, and A is nothing but gain. A is nothing but the voltage gain. It means because of your applying the VID, nothing but differential voltage. VID is equal to, yes, you can write VRF minus V. And as usual, the condition of comparator or how your comparator works means in your comparator, if the VRF, the reference voltage is more than Vin. If the reference voltage is more than Vin, then what will get output? Will get output positive saturation. Will get output positive saturation. Condition is that if the reference voltage is more than the Vin, in that time we will get the output voltage, we get the positive saturation, or we will get right in positive VCC. In the same time, if the reference voltage, if the VRF is less than Vin, then we may get V0 equal to minus saturation, or we may get minus V. It means actually depending upon the which input is very more, we get the output. Especially we want the whatever applying to the non-inverting terminal, that whenever it is more, we get the positive saturation. If this it is very less, we get the negative saturation. In the overall, the important thing, the comparator will compare the two signals with respect to the with respect to the VRF, they are comparing the Vin. This VRF is constant, you can take it any value. This reference voltage is compared to the input voltage. This reference voltage is compared to the input voltage. And the condition is that if the reference voltage is more than Vin, we will get positive saturation. And if the reference voltage is less than Vin, we may get minus saturation. This is about in brief about your comparator. And the thing is that in comparator, it is also most important thing, application of comparator, as I said at the beginning, it is used as an analog to digital converter. Because in the input you are applying the analog signals, but in the output you may get positive saturation or you may get negative saturation. Yeah, you can convert easily the analog into digital, because as we know in digital also there are only two conditions. It may be high or low. We can have in digital, in analog, in digital, where only the input may be low or high, or it may be 0 or 1. Same thing happens here, the output may be positive saturation or output may be negative saturation, or the output may be 1 or output may be 0. It means the most important thing about comparator, it is a type of amplifier. The important thing, it working on the principle of open loop configuration. You are not applying any feedback, and also it will compare the two input signals, and depending on which input is more, they will give the output. In this two input, which input is very more, that will give the output voltage. It means as I said here, the important thing is condition is about the comparator will compare the input voltage with respect to the some reference voltage. And thing is that if the reference voltage is more than Vin, we may get positive acceleration. If the reference voltage is less than Vin, we may get minus acceleration. This is about the importance about the comparator. And now we look for another important thing. What are the important applications of your comparator? Actually, where you are using the comparator. The applications of comparator. Applications of your comparator. In your comparator, it is used in your zero crossing detector. Zero crossing detector. And also it is used as a schema trigger. Schema trigger. The most important applications of your comparator. Comparator is used as a schema trigger. It is also used as your zero crossing detector, and also it is as a schema trigger. It is used as a schema trigger. And the important thing, how your comparator uses a zero crossing detector and how it is used as a schema trigger. And also if you want to convert the analog and digital, as I said in the beginning, it is used the comparator. Comparator also used to convert analog and digital signals. It is also used in oscillator. It is also used in your discriminators. But according to your syllabus, we are having only the zero crossing detector and we are having the schema trigger. The zero crossing detector and schema trigger. The main application of comparator, the comparator uses a zero crossing detector. It is also used as a schema trigger. And actually, what is called zero crossing detector? What is called zero crossing detector? And why it is called zero crossing detector? You see here, it is called zero crossing detector. You see, as usual, you are using a comparator, and especially in comparator, there are two types of comparator. Before that, we can look earlier. There are two types of comparator. Types of comparator. One is called inverting comparator, and another one is non-inverting comparator. Inverting and non-inverting comparator. Very simple. In inverting comparator, you are applying input to the inverting terminal. But in non-inverting comparator, you are applying input to the non-inverting terminal. It means depending upon the way you are applying input, depend on the two side comparator, inverting comparator, non-inverting comparator. In inverting comparator, you are applying input to the inverting terminal. But in non-inverting comparator, you are applying input to the non-inverting terminal. That's why I done about two types of comparators. And here you are considering in your zero crossing detector, you are considering the non-inverting comparator. In your zero crossing detector, you are considering the non-inverting. Here you apply the input. You are applying input to the non-inverting, and you are applying the reference voltage. Negative reference voltage is ground. Argument VRE is 0. And as usual, you are using an positive VCC and negative VE. And here you may get ground. And what is the importance of zero crossing detector? And as I said, the zero crossing detector is also type of comparator, and it also compare the two signals. It also compare the two signals. The important thing here is that if your Vin, if the Vin is greater than 0, what you get? We may get output positive saturation. We may get the positive saturation. And if your Vin is less than 0, we may get V naught is equal to minus saturation. It means especially because this Vin, the input voltage is compared to the reference voltage, and now in this zero crossing detector the reference voltage is 0. It means if the input voltage is more than the reference voltage, then what are, if your input voltage is more than 0, you can say V naught equal to positive saturation. If this Vn is less than 0, we may get negative saturation. It means here we may get comparator will compare the two signals, and output may be positive saturation or output may be negative saturation. And why it is called zero crossing detector? It is so important for 2 mark question. They ask in exam why it is called zero crossing detector. Because it is called zero crossing detector. Why? Because whenever the input voltage crosses the 0, whenever the input voltage crosses 0, what happens? Output may change the state. They may go to positive saturation or they may go to the negative saturation. That's what is called as zero crossing detector. Once I repeat, the zero crossing detector on the word, whenever the input voltage crosses 0, whenever the input voltage crosses 0, the output may change. It may change positive saturation or it may change the negative saturation. That's what is called as zero crossing detector. What is zero crossing detector? It is a type of comparator. Here, whenever the input voltage crosses 0 in the positive direction, we may get the output also in the positive saturation. If the input voltage move towards the negative side, we may get negative saturation. Or in simple way, whenever the input voltage crosses 0, it may towards the positive side or it may towards negative side. Your output may changes, or your output will changes from positive saturation to negative saturation, or negative saturation to positive saturation. That is something called zero crossing detector. The zero crossing detector on the but whenever the input voltage crosses the 0, your output will change the state, or output will change the state. It may go to positive saturation or it may go to negative saturation. That is something about the importance of your zero crossing detector. And especially in your zero crossing detector, if you apply the input, as sine wave, if you apply your input as sine wave, your input, and we may get the output as square wave. We may get the output as square wave. We may get the output as square wave. This is also an important application of our zero crossing detector. In zero crossing detector, if you apply the input as sine wave, we may get output as square wave. That's why I said the comparators used in your analog crystal converter. If your input is analog, as we know the example analog is sine wave, example for digital is square wave. If you are applying the input as your comparator to the analog, we may get output at the output we may get the square wave, or we may get output at the system. Input is analog, output is digital. This is about in brief about your zero crossing detector. And I will go for finally go for the schematic trigger. We will go for the schematic trigger. It is also another important application of your comparator. Schematic trigger. Look here for your schematic trigger. Actually, you are considering the in your zero crossing detector or in comparator, you are not considering the feedback. But what is schema trigger? It is the schema trigger. It is also type of comparator, but important thing here you apply the positive feedback. A schema trigger, it is circuit. It is having the positive feedback. The schema trigger basically it is an comparator, but important thing you are applying a positive feedback. A schema trigger, it is a circuit or device. It is basically a comparator with positive feedback. That is something called schema trigger. And as usual, you consider your the important thing. It is also nothing but here you can apply then input. You can apply the input mean, but here you can apply the feedback. You can apply the this is nothing but your R1, this is nothing but R2, and this is nothing but your A reference. And this is nothing but your positive, this is nothing but your negative. It means basically the schema trigger, it is a type of comparator, it is a type of comparator, but here you are connecting a feedback. You are connecting a feedback. Especially that feedback nothing but here the sum part of the output is connected to the non-negative terminal. The sum part of the output is connecting to the non-negative terminal of your op-amp. In schema trigger, you are considering the positive feedback. Why? Because why positive feedback? The sum part of the output is given or is connected to the non-negative terminal of your op-amp. That's what is called as positive feedback. In your schema trigger, the sum of the output is given back to the input, and this you are giving some part of the output that is connected to the non-inverting terminal of your op-amp. That's why the schema trigger, it is something but it is working on the principle of positive feedback. The schema trigger is a comparator, it is having the positive feedback. And as usual, here also same thing, the output may positive saturation or it may negative saturation. Output may be negative saturation. But important thing here, once again same, if the reference voltage is more than V, same as usual, if the VRF is more than V, we may get output may be positive saturation. And if the VRF is less than V, then V not be negative saturation. But you are having this R1, R2, they are using a voltage divider by C. Actually, you can write here because some of the voltage drop versus R2. You can write the V reference. You can write V reference equal to beta into V naught. Beta into V naught. Now the beta equal to the feedback factor. How much the voltage drop across here? The beta you can write the beta equal to R2 divided by R1 plus R. R2 equal to beta equal to R2 divided by R1 plus R. Or you can write V reference equal to beta into positive saturation, or V reference equal to beta into minus saturation, where beta equal to R2 by R1 plus R. P not nothing but positive saturation or negative saturation. This is about the importance of your schema trigger. The important thing schema trigger, it is a type of comparator. You are using again positive feedback. You are using again positive feedback. in your comparator. And also the important thing about the comparator is about if you apply any input signal, any input signal, always give you the output as square wave. Any regular or irregular shape of the input given, always you get the output as square wave. It is also called as square wave generator. The most important thing about your schema trigger, always the schema trigger will give the output as square wave. The input may be the regular shape or irregular shape. Always output should be in the square wave. It means in your schema trigger, once again your input may be the sine, or it may be your square, or it may be triangular. In all the cases, the only thing is that we may get the output as square wave. Whatever may be the input, always output should be the square wave. This is about in brief about schema trigger and zero crossing detector. And as compared to the zero crossing detector and schema trigger, we prefer the schema trigger. Why we prefer schema trigger? Because it will reduce the noise. As in your zero crossing detector, if the input voltage is more than 0, we may get the output. But here in your schema trigger, the important thing is about if your input is less than V reference or minus V reference, we are not getting output. Always the input should be more than or equal to the V reference, then only you get the output. That is the importance about schema trigger. It means in your zero crossing detector, if the input voltage may increase to 0, if the input voltage more than 0, we may get the output. It means sometimes we may get the noise at the output. But here in schema trigger, always the input voltage should be more than or equal to the positive saturation or negative saturation, then only you get the output. It means you can reduce the noise in your schema trigger. This is about in brief about the schema trigger and zero crossing detector. These are the two important applications of your comparator. Now we'll go for finally last the important thing about the counter type. We go for the counter type. A2 or can write ADC. Can go for the ADC or you can go for the A to D converter. As I said in the beginning, you can easily convert analog and digital signal. There are so many methods are there how you are studying you converting a digital analog signal. There are two methods. One is R to R ladder network. Another one is called your binary video resistance type. Here, according to us, we are having here also we are having so many types. But according to us, we are having the counter type of A to D converter. You are considering the counter type of A to D converter. You are having successive approximation method, or also you are having the counter type of ADC. But according to your syllabus, we are having only the counter type of A to D converter. And as I said, it is having in the beginning I said it is having